Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 17, 2025, just 2 days ago. The standout idea is reframing interleaved image and text generation as tool use, where a central planner calls different visual tools, which leads to state-of-the-art results and near-perfect tool invocation with 100.0% tool accuracy on LLM-I bench. The paper is titled, LLM-I, LLMs are naturally interleaved multimodal creators, and as we'll see later, the results are really impressive. Beyond accuracy, the framework uses reinforcement learning with hybrid rewards and test timescaling to boost factuality, precision, and flexibility. On X, one post highlights the release and title, while another thanks the team and echoes a long-standing call for a vision toolformer concept engagement appears modest with under 100 likes. Also, the authors shared an open-source repo. You will find a full LLM-I agent framework with examples, Docker and scripts, system prompts, image utilities, and evaluation code. It includes tool integrations for search, diffusion, image edit, and code execution, plus judge servers, setup instructions, and GRPO training recipes for QN models. Alright, the previous figure introduced the release and tooling, and Figure 1 presents the end-to-end workflow. Figure 1 shows a user query routed to an LLM planner that emits ImGen tags, which trigger tool calls for search, diffusion, code, or edit. The toolkit returns images that are scored by rule-based checks and by judges, so the policy updates toward reliable tool use. The diagram emphasizes factual grounding through search and precision through code, while diffusion and editing handle creative or corrective needs. So, Figure 2 details the test timescaling pipeline that sat on top of the policy. Figure 2 shows multiple sampled responses passing a tool call check, after which a selector keeps the top K candidates so malformed calls get filtered out. The kept candidates trigger parallel enhancement. Search and diffusion both return images that a judge selects between, while failed code gets revised and rerun in a sandbox. The polished candidates then flow to a final selector, which picks the best interleaved output. Well, the previous figure outlined the scaling pipeline, and Table 1 reports head-to-head results on the OpenING benchmark. Table 1 shows that the LLM-I models score highest overall, with strong gains in completeness, correctness, and human alignment, which signals more coherent and useful interleaved outputs. The table also lists image-text coherency and multi-step consistency, and those columns favor the tool using variants because the planner can pick search, code, diffusion, or editing as needed. The takeaway is broad wins across metrics rather than a single narrow boost. So, while Table 1 showed broad wins on OpenING, Table 2 reports results on LLM-I bench. The table compares rubric scores, human ratings, tool accuracy, and an overall score, which matters because the benchmark stresses complex mini-projects. The LLM-I 4B and 30B models reach 100% tool accuracy and lead overall, with strong human and rubric scores. Baselines with tools trail notably, and the mid-sized MLLM models also rank high, showing the planner generalizes across backbones. Alright, the previous table showed wins on LLM-I bench, and Table 3 now reports results on the ISG benchmark. Table 3 lists 4 metrics, covering structural layout, holistic quality, block coherence, and per-image scores. The LLM-I 4B and 30B models top every column, which signals stronger structure and tighter text-image consistency than unified or two-stage systems. The mid-sized MLLM-I variants also improve markedly over base QN models because the planner selects the right tool for each visual need. Wrapping up, 2 takeaways stand out. Treating interleaved generation as tool use lets a planner pick search, diffusion, code, or editing, which lifts factuality and precision, and the hybrid reinforcement learning plus test time scaling reliably executes those choices at high accuracy. The broader implication is modular multimodality. Add tools, not monoliths. Thanks for listening. I am Alex.